Here is how you observe and calculate parallax. Parallax is the apparent change in angular position of a nearby object due to the change in viewing angle by the observer. In other words, when you as an observer is the one who is moving, then nearby objects will appear in different directions relative to you. In this demonstration, I am moving the camera around, which causes an apparent shift in the direction of the green pen, as well as other objects around. Parallax is a useful way of deducing distance. Closer objects will appear to shift more than farther objects. In fact, this is an important part of how depth perception works. You can try this out on your own by holding a pen at various distances, blinking your eyes, back and forth between the left and the right one. The angle that is observed will depend on both the distance to the object as well as the distance between the two viewing positions. Human depth perception is limited to several dozens of meters only because our eyes are usually no more than about 10 centimeters apart. To measure cosmic distances, we need a lot larger baseline. Earth's orbit provides this distance. Because one astronomical unit is about 150 million kilometers, in the span of 6 months, the Earth will be 300 million kilometers from its previous position. If we make some initial observations of a nearby star and then make observations of that same star 6 months later, we will be able to record the parallax of that star and hence deduce its distance. For further demonstration of these calculations, we now turn to the simulator from the University of Nebraska-Lincoln Astronomy website. This calculator shows the overall sketch of the geometry involving the nearby star, its distance from our solar system, and Earth's orbit. The parallax angle measurement we are interested in is denoted by pi. Because stars are very far away, the angle of the parallax is given in arc seconds, which are 1/3600th of an arc degree. The unit of distance is usually given in parsecs, which is the equivalent distance where the parallax will be observed to be exactly 1 arc seconds. This distance is equivalent to about 3.26 light years. To use the calculator, simply type in the observed parallax of a hypothetical star, and it will automatically calculate the distance for you in parsecs and equivalent light years. You can use the calculator in reverse as well. If you have a hypothetical star at, say, 100 parsecs, it will calculate the distance in light years, as well as back calculate what would be the observed parallax. You can also manipulate the third entry box as well. Some of the top telescopes in the world have an angular resolution up to 1/1000th of an arc second. This means that they can, in theory, deduce the distances to stars 1000 parsecs away, or about 3000 light years in distance from our solar system. Unfortunately, that will only get us measurements to our immediate galactic neighborhood. Distances to globular clusters, as well as the overall size of our galaxy, are much larger. To deduce those distances, you will need to use the next step of the cosmic distance ladder. That step and others are the subject of a different video.